Welcome back to the Electrical Building Design Show. I've pulled up the Revit 2023 electrical sample project. We're going to walk through this project in this episode and take a look at how it's put together. A quick background on this project. Autodesk replaced it in Revit 2024 with a new sample project. This project was the sample project going back to at least Revit 2013. That's when I really started getting into Revit, and so this was the sample project at the time. Revit MEP came out in 2006. I'm not sure if this was the sample project between 2006 and 2013 or not, but certainly from 2013 to 2023, this was the sample project that Autodesk was shipping with Revit. I've opened up the project, and this is actually the sample systems project. So this is for electrical, but also for mechanical and plumbing. You can see the initial view that it opens up to here, and it's labeled main electrical distribution. If I zoom in, you can see that it's got the levels of the building. It has the service transformer and a number of the panels, some of the feeders running between them. I think the idea behind this view is that they were thinking it could be used as a single line diagram, but it really highlights the fact that you can't use a 3D model for a single line diagram. If you start to actually include all of the panels, they start obscuring each other. It's really hard to cut a section that shows all of the panels in your project. Drawing the feeders in 3D is actually a little bit tedious. You can see that Autodesk, even in their sample project, they drew in 3 or 4 feeders, and then they stopped because they didn't want to keep going. We're going to be using ElectroBIM to navigate through this project. One nice feature of ElectroBIM is it lets us generate a one-line diagram from the equipment in the model. So we're going to start by doing that. First, we'll generate what we call a one-line diagram. So I'm going to make a drafting view. And I'm going to generate the one-line diagram on this. In ElectroBIM, we differentiate between a one-line diagram and a riser diagram. We collectively refer to all of those as single-line diagrams. A one-line diagram we draw in this configuration where it's a top-down tree configuration of all of the equipment in the project. And then the riser, which we'll generate next, goes left to right and actually takes into account the elevation of the panels in the building. There's our one-line diagram. You can see that we've got a utility transformer up here at the top. There's a switchboard that's feeding these 3 panels here. So that's kind of how it's configured. We kind of got 3 sections in the project. Let's take a look at what that looks like in a riser view. So I'll create another drafting view, and we will generate the single line diagram as a riser on this drafting view. There's the single line generated as a riser. We can see, again, we've got the utility transformer, that switchboard, and then the 3 sections. They're actually on separate levels in the building, so that's why they're separated like this. So we can start to see how the panels are arranged in the building using a riser. Which you actually use in your project is really your personal preference and what the project calls for. We have these 2 generate options to help support it. We have the riser, obviously, and then we have the one-line diagram. Neither of these are 100% what you would want it to look like when it goes out. This is just the first draft of the drafting. From here, you would do some modifications to get the drafting to a point where it's something that you'd want to publish. But it's a good starting point for the layout of your devices on your single line diagram. Zooming in on the equipment, we can start to take a look at how this is all configured in Revit. You can see that this transformer is set to 75 kVA. And so is this one. So the kVAs aren't set all that well because they're all being seen as 75. We'll take a look at what's going on with that. Also, the switchboard, it has a bus size of 0 amps, and everything else is currently set to 100 amps. So the actual electrical definition of the equipment in this project is not great. Let's go ahead and take a look at MDP1 and see what's going on there. I can run our highlight device command and select MDP1 and see where it is in the model. It's located here on this plan. Selecting that panel, you can see that the type is labeled as 400 amps. But if we scroll down in the properties, the mains value is set to 100 amps. So we have this disconnect between the 400 here and the 100 here. This 400 is strictly a text label. It actually has no connection to the electrical definition. So this is a place where they chose a type that they labeled 400 amps, but they didn't actually get the electrical definition to match for that piece of equipment. If we take a look at the transformers, we have a similar thing going on. We have a transformer over here. If I select this transformer, you can see that it's labeled 15 kVA, but Revit doesn't actually have a kVA parameter anywhere for a transformer. So that's not specified anywhere. So when ElectroBIM looks at that transformer, it doesn't know the size of it. That's why everything came in as 75 kVA. That's our default transformer size. Taking a look at that panel again, you can see also that the MCB rating is also 1 amp. So that's not set properly either. I'm going to clean that up and add values that are a little closer to correct for all of the equipment in this project. So as we look at some of the calculations, they're going to make a little bit more sense. Okay, I've updated all of those bus sizes and transformer sizes to match the value specified in the type, so that they're at least closer to matching the design intent of this project. If we go take a look at the riser diagram in ElectroBIM, we can see that it has updated those values to match, so that this transformer is now 15 kVA. We have a 125 amp panel. This panel has been updated to 400 amps. ElectroBIM links your single line diagram with your Revit model, so as you're making changes to one or the other, they're both being updated. That way, as we make all these changes to those pieces of equipment, the single line diagram is updating at the same time. Let's take a look at the panel schedule for MDP1. You can see here that the mains rating has been updated to 400 amps. All of the trip sizes on the breakers have been updated as well. Again, all of that's being changed at the same time as we're making those changes on the single line diagram. The MCB rating is still 1 amp. That's because that's being pulled from the default Revit value. ElectroBIM actually replaces that with our own parameter. So I'm going to take a moment, redefine this panel schedule, use our parameter, and then we can see that being updated also. I've updated the panel schedule template. You can see that the MCB rating is actually specified as MLO, meaning main lugs only. So in ElectroBIM, we've specified this panel to be main lugs only. We can modify that. So let's run our panel edit command, and we'll change the disconnect type from a main lugs only to having a main breaker. And currently that breaker is going to be sized the same as the bus. And we can see that the main circuit breaker rating has now updated to match the size of the panel. Using those panel sizes, ElectroBIM sizes the feeders between the panels as well. So now we have correct feeder sizes in our project. In the Revit model, we know where everything's located, so we also can calculate the feeder lengths as well. Using that information, we can calculate fault and voltage drop in the project. Let's take a look at our fault schedule here. You can see that it's calculating 24,000 amps at that utility transformer. We can modify that in ElectroBIM, get the value that the utility gives us, change that to 65,000 amps, and then update our calculations. And we can see that the fault in the project at all of our panels has been updated to reflect that new starting fault. We can also take a look at the voltage drop calculation. Here we have the voltage drop on the feeders. This is the cumulative voltage drop from the utility, and then also the voltage drop on each of the branch circuits. It's really showing us the maximum voltage drop there, so the largest branch circuit voltage drop, and then the total voltage drop from the feeder and the branch circuits. We have that for the entire project as well being calculated. ElectroBIM is upsizing the wires to account for voltage drop based upon thresholds that we've specified for the project. We can take a look at the voltage drop review schedule, and this will show us all of the feeders and branch circuits that have been upsized. This schedule helps the engineer backcheck what the software is doing so that the engineer understands which wire sizes have been increased and has a chance to review those. ElectroBIM takes over sizing of breakers and also has the ability to take over setting circuit descriptions as well. When you do that on an existing project like this, you can get some values that are a little bit different after you run our calculations. We have this circuit value comparison schedule that we create to show you where those values have been changed in the project. This way you can see what's been modified and then account for it appropriately. I'm going to sort this by breaker size. That way we can take a look at which breakers have been updated by ElectroBIM. At the top, you can see that all of these breakers from panels that are being fed from transformers, they've been changed from 20 amp breakers to 0 amp breakers. That's really because there's actually not a breaker there. Typically on a transformer, you don't have a breaker. So ElectroBIM is recording that as 0 amps rather than the 20 amps that Revit was giving it. Then you can see that there are a couple of branch circuits that used to be at 30 amps and are now 20 amps. If we scroll down to the bottom, there's a big group of them here. Those are all HVAC equipment, and they're smaller loads, 11 or 15 amps. So ElectroBIM is seeing that and sizing it to 20 amps They were upsized to 30 amps, presumably because that's what the equipment actually calls for. In a case like that, you could either modify the equipment through ElectroBIM or the circuit itself to get the breaker to be the right size again. Scrolling down to the bottom of this schedule, you can see a bunch of 100 and 400 amp breakers that used to be 20 amp breakers. These are all the breakers on the feeders to subpanels, and these apparently were never sized properly for this project, so they were left at the Revit default of 20 amps. ElectroBIM has properly sized those for us to breakers that actually match the downstream panels. We also list the new and the old circuit description. I'm going to adjust these columns so we can see that a little bit better. For these branch circuits, you can see that there's a little bit of a difference in how we're labeling the rooms. Revit out of the box will list a room the circuit is on. ElectroBIM out of the box will list all of the rooms that a circuit is in, so it gives you a little bit more information on the circuit description for your rooms. You can also see up at the top that there are a number of feeder circuits that were mislabeled. The panel name and the circuit description didn't actually match. So the panel name is PP1A, and that's what ElectroBIM has updated the circuit description to. It previously was being labeled as PP1B. If we scroll down to the bottom, we have some places here. All these transformers were TP1B, and now they're TP3A. So some of the numbers have changed, and those B's have been changed to A's. So ElectroBIM updating your circuit descriptions keeps things a little bit more synchronized, because Revit, once it puts a circuit description in, doesn't actually update it when you make changes to the project. So you can end up with situations where your circuit descriptions and your panel names don't actually match anymore. ElectroBIM helps avoid that inconsistency in your project. That's the Revit 2023 sample project. It served its purpose well for over a decade, providing a decent sample project for people to look at when opening up Revit. It had some quirks and some issues with it. It's certainly not something that you would publish or construct from, but as a sample project, it worked pretty well. Now Revit has the new 2024 sample project. You can see my review of that in another video that I will link up in the show notes. If you want to learn more about ElectroBIM, you can go to our website, designmaster.biz. We have a free trial available there. You can download it and try it out on your projects and see how it works on those.